Hey everyone, and welcome back to the podcast. I'm Mark, and as always, I'm here with Jenny. Jenny, are you ready for some serious battery talk today?
Mark, I was born times ready. I've been hearing whispers about some ultra-cheap battery breakthroughs. Is this the real deal or just more tech hype?
Oh, it's real. And it's asterisk way times more than whispers. We're talking about advancements that could slash battery costs by more than half. I'm talking 50 to 60% reductions. And that's mainly because of something called dry electrode manufacturing.
Okay, dry electrode manufacturing. That sounds dry. Explain it to me like I'm, say, someone who hasn't spent the last decade immersed in battery tech.
Right. So, basically, traditional battery making involves mixing all the active materials with these solvents. It's like making a cake. You need the wet ingredients to bind everything. But these solvents are expensive, toxic, and require huge, energy-guzzling ovens to evaporate.
So dry means they're skipping the messy, expensive solvent step?
Exactly. They've figured out how to press the materials together directly, without the solvents. It's like making a cake without any liquids, somehow. It's a bit more complex than that, obviously. But that's the gist.
That sounds like it would save a asterisk ton times of money and energy. Smaller factories, less pollution. Phew. I'm starting to see why you're so excited.
And that's just one times part of it. There's also this, iron trichloride cathode material. Now, this is where things get really interesting from a materials science perspective.
Hold on. Let's not get lost in the chemistry times yet. What's the big deal about iron trichloride?
Okay, so most batteries today use lithium-based cathodes, right? Like lithium iron phosphate or LFP. But lithium, it's getting more expensive, and there are concerns about where it's sourced from.
Right, the whole geopolitical side of battery production.
Precisely. Iron trichloride, though? It's dirt cheap. We're talking about reducing the material cost to less than 2% of what LFP costs. 2%! And iron is abundant.
So we're swapping out a relatively rare and expensive material for something that's practically everywhere. That's a big deal. But does it times perform times as well?
That's the thing. It's getting there. There was a team at Georgia Tech, led by a researcher named Hailong Chen, and they've been working on this. Their tests show it can achieve similar performance to LFP, and in some cases, even slightly times better times energy density.
Slightly better? So, cheaper and times potentially better? This sounds too good to be true. What's the catch?
Well, it's still early days. Scaling up production, ensuring long-term stability, those are always challenges with new battery chemistries. Chen himself said we're probably looking at 5 years or so before this is widely available.
5 years in battery development time. That's practically tomorrow. So we've got dry electrode manufacturing, cutting production costs, and iron trichloride, slashing material costs. What else is brewing in the battery world?
Oh, there's plenty. We've got solid-state batteries, which everyone's been talking about for years. They promise higher energy density and better safety. But they're still expensive to produce.
Right, the holy grail of battery tech, but still out of reach for most applications.
And then, there's Tesla. Always a wild card. They're working on aluminum-ion batteries. Now, that's times interesting because aluminum is even more times abundant than iron.
So another move towards cheaper, more readily available materials?
Exactly. And they're claiming some pretty significant cost reductions. We're talking about potentially making electric vehicles much times more affordable. Like a 75% price reduction compared to current models.
75%? That would put EVs in direct competition with even the cheapest gasoline cars. That's a seismic shift.
It is. And it's not just about cars. Think about grid-scale energy storage. Cheaper batteries mean we can store more renewable energy, making solar and wind power even more viable.
Okay, so it's not just a tech story, it's an economic story, an environmental story. It's a asterisk everything times story.
Precisely. And there's even this angle of eliminating our dependence on rare earth materials. That has huge implications for global supply chains and even national security.
It's like we're moving away from this era of resource scarcity and towards resource abundance, at least when it comes to batteries.
And that opens up possibilities we haven't even imagined yet. Think about developing economies, having access to affordable energy storage. It could be transformative.
So, What's the bottom line here, Mark? What should our listeners take away from all this?
I think the key takeaway is that battery technology is evolving times rapidly. And it's not just about incremental improvements anymore. We're seeing breakthroughs that could fundamentally change the way we power our world. And it's happening time fast.
And it's not just about one technology winning out. It's about this whole ecosystem of innovation, with different batteries for different applications, from iron trichloride to aluminum ion to who knows what's next. It's an exciting time.
It is. And we'll be here, breaking it all down, every step of the way. Thanks for joining us, Jenny.
Always a pleasure, Mark. And to our listeners, thanks for tuning in. We'll be back next week with more explorations into the world of tech.